Dears, now it's part B. In the part B, we are moving to see the chemical reactions mainly. Combustion reaction, oxidation reaction, addition reaction and substitution reaction. Then the important things like ethanol. What is the speciality and properties of ethanol, how it will react, all these we will see. About ethanoic acid, and then about the esterification reaction. What is this esterification reaction? What is the benefit of it? All these we will see. Then saponification reaction, and then we will discuss soaps and detergents. Okay, ma'am? First one is combustion reaction. Combustion reaction, what is happening, ma? Any carbon when exposed to air, what will happen? It will absorb oxygen and it will react, which liberate carbon dioxide. Along with that, what will be the heat as well as light. Okay. Carbon plus oxygen gives carbon dioxide plus heat and light. Heat will be much more. That's why this carbon is used for fuel. We have learned it in the 8th standard itself. Coke, then petrol, petroleum products, all these contain carbon, which is used as fuel because when it is exposed, it will give enough heat and enough light also sometimes. Then about ethanol or any alcohol, it can be CH3CH2OH. This is ethanol. When reacts with oxygen, what will we give? Again, carbon dioxide plus heat and light. That's why alcohol should not be exposed to fire. When is kept outside, what will happen? It will burn vigorously, giving carbon dioxide as well as this much heat will be liberated. Okay, when we are saying, we have to notice one thing. That is, we have learned while we were learning about the hydrocarbon, we have learned saturated as well as unsaturated, right? When the saturated hydrocarbon, when exposed to air, it will burn with blue flame. That's what in the gas stove we are getting blue flame, which means combustion will be complete. Combustion is complete. In the 8th standard itself, we have learned combustion and fuel. By the time everything has been discussed, if you want, you can go and see the link. Okay, ma? When we are burning the saturated hydrocarbon, the flame will be blue and the combustion will be complete, giving full heat. But in the case of unsaturated hydrocarbon, when it is exposed, what will happen? When it is exposed and allowed to heat, it will heat with yellow flame and it will be sooty yellow flame. So that when we are keeping a vessel over it, for example, wood, when we are heating it, it will not burn in blue flame. Always will burn with yellow flame, and when we are keeping a vessel above it, it will be fully black, which means ash of carbon will be that has been will be deposited on the vessels. Moreover, when we are burning some fuels which contain along with the carbon some other functional groups or other electronegative things like nitrogen, sulfur is also present. It will cause pollution, which gives you smoke much more. All these will be happen. So saturated hydrocarbons has to be heated, then we will get the blue flame. Okay, ma? This is the main thing about the combustion. Then we can move for oxidation. What is oxidation? Addition of oxygen is oxidation. See, ma, CH3CH2OH has to be converted in such a form that one more oxygen is added. Here, how many oxygens are there? Only one. Here, how many oxygens are there? Two. So, which is helping for adding oxygen is called oxidizing agent. It can be alkaline KMNO4 or acidified K2Cr2O7, potassium dichromate or potassium permanganate in the presence of heat. Delta Y I have written is in the presence of heat. What will happen? It will be changed. Alcohol will be changed to acid in the presence of this KMNO4 or K2Cr2O7. So we are saying these two as oxidizing agent. Moving for the third one, that is addition reaction. What is addition reaction? One is addition reaction. Here unsaturated alkane or unsaturated one hydrocarbon will be converted into saturated hydrocarbon. Okay, ma'am? Here carbon double bond is seen, which means that it is unsaturated, and this unsaturated will be converting into saturated one with the help of catalyst, either nickel or palladium, any catalyst we can use in the presence of hydrogen. hydrogen, this double bond will be converted into single bond, while this carbon will be attached to one hydrogen and this carbon will be attached to hydrogen. So what will happen? CH3, the C double bond, C here R, C double bond, C, R will be changed into 2R, and one hydrogen will be attached to this carbon and one more, it will be bonded to one more carbon, and the same thing will be seen. So which means that unsaturated has been converted into saturated one. Similarly, they may ask, we know that vegetable oil is what, saturated or unsaturated? It is unsaturated. How can we convert the vegetable oil, unsaturated vegetable oil into the saturated ghee? They may ask in that manner. We have to write that when it is exposed or when it is allowed to react with hydrogen in the presence of catalyst nickel or palladium, we can convert the unsaturated one into saturated and we will get the saturated vegetable oil, or it will be converted into vegetable vanaspati ghee and all, it will be converted. It may ask for your question. Then the last one is substitution reaction. Substitution reaction is any of the hydrogen atom is replaced by some other things, to say halogen family, chlorine. Here chlorine has been seen, CH4, methane here when Cl means Cl2 is acted, this hydrogen and this chlorine will be removed, and in the case of this, one hydrogen is replaced by chlorine to form chloromethane. It is called chloromethane. Methane converted into chloromethane and HCl will be released in the presence of what, ma? In the presence of sunlight it is doing. Okay, ma? So these are 4 chemical reactions. Now we are moving to see ethanol. Dears, now we are moving to see about ethanol. Ethanol, there are many types of ethanol. Kana? Rectified spirit, that is alcohol with 5% of water. Alcohol with 5% of water, we are saying it as rectified spirit, or we are saying it as spirit. For this purpose, spirit, that is ethanol is used for the for drinking purpose. It's then absolute alcohol, that is without water. 5% of water is also not there. That is absolute alcohol. That is 100% alcohol is called absolute alcohol. Then denatured alcohol. Ethanol we are using for the drinking purpose are rectified spirit, and the absolute alcohol we will not use maximum. But the denatured alcohol is ethanol which contains methanol also. Methanol is highly poisonous. We should not use it at all. So for the industrial purpose, this methanol and ethanol will be mixed for various purpose and all. This ethanol is needed for that. When methanol is also mixed with it, it is called denatured alcohol, and when we are drinking it, it may cause much more danger. Even the death may be also caused. So for making the people aware of it, they may mix blue color to it, so that we will come to know that it is denatured alcohol, and the people will not drink it. So for that purpose, it is for industrial purpose we are using this kind of alcohol. So it is called denatured alcohol. These are the various types. Now we are moving for the properties of ethanol. In this, which form it will be ethanol always? Or ethanol will be in the form of liquid. It is in the liquid form at the room temperature. When sodium is reacted with CH3CH2, that is ethanol, sodium ethoxide is formed, that is hydrogen will be replaced by sodium. So we are saying it as sodium ethoxide plus H2 will be formed. Then the next reaction is when the same thing is the ethanol, I have written it in this form, CH3CH2OH. Okay, when treated with concentrated sulfuric acid at high temperature, that is 443 Kelvin, what we will get is this hydrogen and OH will be removed. This water will be removed by this concentrated sulfuric acid, giving what, ma? Giving a double bond over here to form CH2CH2. What is it? Ethene is formed along with water. So dehydrating nature is there for what, ma? What is dehydration? Removal of water. That is the specialty of this concentrated sulfuric acid, to remove water from alcohol. What we are using? This concentrated sulfuric acid is. Dears, now we are moving to see ethanoic acid. Ethanoic acid is also called acetic acid. Okay, this is a type of carboxylic acid group. That is COOH is there at the end. So we are saying it as carboxylic acid, and commonly the ethanoic acid is called acetic acid. The solution of acetic acid, that is 5 to 8 percentage of acetic acid in water, is called vinegar. You may have heard about the word vinegar many times because it's used for the preparation of or preservatives. It is acting as a preservative in pickles and all. This vinegar is used in large quantity. Now about the melting point. Melting point of this acetic acid or ethanoic acid is 290 Kelvin. Okay, 290 Kelvin it is having the melting point. And during winter season, what will happen? During winter season, it will cool and it will freeze. So when it is getting freezed, we are saying it as glacial acetic acid. These are all the physical properties of this ethanoic acid. Now we are moving to see some chemical properties. CH3COOH, that's what ma? It's ethanol, ethanoic acid. When treated with ethanol, that is, when ethanoic acid reacts with ethanol, we will get ester. We are getting what ma? We are getting ester. Esterification reaction. So that means from the ethanol, CH3COOH is there, no? This OH and one hydrogen will be saying by CH3CO or CH2CH3. That is ester. That is COO group will be there, but at the end hydrogen will not be there. Instead of some other alkyl group will be added. What is the formula of this carboxylic acid? CH3COOH, isn't it, ma? This is carboxylic acid, or this is called ethanoic acid. Here this hydrogen is replaced by any alkyl group. What will be that? Alkyl group means CH3, CH2, CH2, CH3 or CH3 or any other alkyl group. Any hydrocarbon group, when it is replacing, we are saying it as what, ma? When it is there, we are saying it as ester. Esterification. Okay. This ester will be having pleasant smell. Smell is so pleasant, so that it is used for what, ma? Perfumes. For making perfumes, this ester is used in a large quantity. Okay, yes. When we are saying about perfumes, the smile I can see in your face. Okay. Now, when this ester is treated with sodium hydroxide, we will get the reaction back. Okay. When this ester is treated with NaOH, what is that? It is called alkali. When we are treating with NaOH, what will we get? We will get CH3COONA plus CH3CH2OH. That is, alcohol will be get. Then sodium salt of carboxylic acid. Sodium ethoxide is obtained. This is very important because for making soaps and detergents, this process is done. So we are saying it as saponification reaction. What is it called? Saponification reaction is very important. Then some other reactions are also there. CH3COH plus NaOH. Sodium hydroxide will treated with ethanoic acid, we will get CH3COONA plus H2O. Not only with sodium hydroxide, but with carbonates and bicarbonates, the same thing will be obtained. CH3COONA plus some other byproducts will be obtained. These are the properties of ethanoic acid. Now we are moving for this important thing, that is soaps and detergents. Now we are moving to see soaps and detergents and how they are functioning. Same soaps. Soaps, as I told you, esterification, it is opposite of this esterification, that is saponification reaction. When the ester is treated with sodium hydroxide and all, it will be sodium salt of this carboxylic acid is formed, and we are saying it as soap. For example, C15H31COONA. So how much long it will be? How many carbon atoms itself is there? 15 carbon atoms is bonded, and hydrogen atom 31, then COONA. This is soap. Formula for this C17H35COONA. These all are some things which helps for formation of the soap. Sodium palmitate, all these the names are like that which is going. Now how they are formed? When the fat or oil, that is fat or oil, when treated with sodium hydroxide, we are getting soap as well as glycerol. This is the formula how we are, this is the equation, this is the way how we are getting soap. Fat and oil, when treated with sodium hydroxide, we are getting what now? Soap as well as glycerol. This type of reaction is called it is called saponification reaction. Then moving forward, detergents. Detergents are nothing other than a salt of long chain benzene sulfonic acid. Just you have to learn what this is the thing how the detergents are formed. Now we are giving more concentration for the soaps and how we are able to remove the dirt from the cloth when we are washing with the soap. Now we are moving to see that. See there, as I told you, this is the long chain carboxylic acid having sodium at the end. So it will be in the form of this. Means there is a carbon here, carbon, this much long it will be, and at the end Na, sodium. So this is the structure of this soap. So soap will be having in this form. This end is hydrophilic end. What is this hydrophilic end? Means this end will attach to water. That is O minus Na plus. This Na plus will be removed and it will be attached to the water part. But this end, this end, the opposite end is hydrophobic end. That means it is not attached to water. This is the end which will be attached to the dirt particles or with the oil. And this end will be attaching directly to water. So these are the two ends which are present in the soap. How we are washing a cloth? We know we will put the cloth in water and we will add soap to it and we will rinse in it and we will wash by pressing and all, and at the end we can see the color of the cloth has been much more brighter while the oil and the dust has been gone. Isn't it, ma'am? How is it happening? This is explaining by here. Same as soap. As I told you, soap is the molecule which has the hydrophilic end and hydrophobic end. Hydrophilic end means the end which is containing sodium at the end will be having the hydrophilic end. It will attach directly to water, while this hydrophobic end, that is carbon chain, that end will be attached to dirt or the oil particles. Consider this as the oil particles. Molecules of soap will be attached to this particles in this manner. Okay, ma'am. And we are saying it as micelles. M-I-C-E-L-L-E-S, micelles. And when we are rubbing, washing, then all these purpose we are doing now, by all the way we are trying to remove this oil. By the time what will happen is, the dirt will be fully removed by this micelle formation and it will be attached to water and it will be in the form of emulsion in the water. And when we are taking the cloth will be devoid of this oil and dirt, while the water will be what, ma? Water will be having the dust particles and the oil will be attached to this water. By this way, we are able to remove dirt and oil with the presence of soap. So, soap is an excellent, soap helps to remove all these because of this carboxylic nature in the soap. Now, in the case of detergents, it is also having this carboxylic nature, but the soaps will not work in the case of hard water because the hard water contain magnesium and calcium salts. In the case of this hard water, detergents are used. When we are using detergents, it will help to remove the dirt easily by formation of micelles. These are the important points which we have to learn in the lesson. And all the things, see, combustion reaction, oxidation, addition, substitution reaction has been done. Ethanol, ethanoic acid, esterification, saponification and soaps and detergent formation also has been done. The lesson is complete. Now this is question time. First question. Elements with different physical properties but similar chemical properties are called elements of carbon having different physical properties but similar chemical properties are called dash. Second one, self-linking property of the carbon is called dash. Self-linking property of the carbon is called dash. Third one, you have to name what it is. CH3, CH2, CH double bond CH, CH3. What is this compound called? Answer this question. Thank you for watching.